Hi everyone. In this session, we are going to discuss about signal flow graph. So normally a flow graph is a graphical representation of the algebraic equations or block diagram. Normally we can convert our block diagram into a signal flow graph, right? So for example, we can just make the nodes, right? The nodes as summing points in the node, and the gain or your feedback, you can convert into a path, okay? So here, nodes and branches are the basic elements of signal flow graph. Node is a point which intersects two or more branches, and there are two types of node. Input node, it's a node which has only the outgoing branches, and next comes the output node. It has only incoming branches, and mixer node has both inputs node and output node. And what are the properties? So directed branches indicate the signal flow graph between two functions. A path is a sequence of branches which in the direction of signal flow. Loop is nothing but which has a feedback, right? We have look how we can explain here is see just further. So for example, if we have a gain here, can just I'm representing it as G, and you have a feedback, and I'm representing it as H, and see the direction. So this one we'll call it as a loop. So, and we have there should be non-touching loop. There will be the loop which is overlapping. So these are the things we should be noted. And what are the characteristics of signal flow graph here is nodes, branches or edge, forward paths and individual loops, non-touching loops. And next important thing to calculate the transfer function here is Mason gain formula. Okay, how you will build the signal flow graph? A first step. The first step here is you have to see the signal flow graph, that is your diagram, and you have to calculate the forward path gain. Okay, how many forward path gains in your diagram? So we'll see how to find the forward path gain, and next comes the and you have to calculate how many individual loops we have and their gains. And next one, you have to calculate the non-touching loops in your graph. And if you have, that is, you have to calculate two non-touching loops. And if your problem exists, three non-touching loops, you have to calculate. If you have four non-touching loops, you have to calculate. That goes on. Okay. And next, and for more important step is, you have to calculate Mason by the transfer function by using Mason gain formula. So this is your formula. C of S is your output node and R of S is your input node. T is your transfer function and P is the ith node and P is ith node for forward pathing. Okay. So here in the formula, what is del here is 1 minus sum of individual loops plus sum of gains in the two non-touching loops minus sum of products of three non-touching loops. It goes on. If your problem has five non-touching loops, you have to go till five non-touching loops. Okay. And you can just take this formula, calculate the transfer function. So, what are the forward path? What is forward path here is, it should start from the starting point and should end at the ending point. Okay. See, it should start at the starting point and should end at the ending point. But we can, if we need, we can just eliminate some nodes. Okay. But your path should start from the starting and it should end at the ending. So your first forward path is this one. Okay, and you have the forward path, right? And next, see which can be done here is this one. This is also a forward path. The others are feedback, right? Feedback, see the arrow marks. Someone can be writing like this, right? So this cannot be a this H2 of S. This cannot be a forward path because it's, and there is another rule. A node cannot be repeated for more than once. For example, I'm drawing a line from input to output in your problem, and it should be flowing through a single line or some curved paths. But the node, right? A node cannot be repeated twice when you're drawing a forward path. So we have two forward paths here. First one is G1, G2, G3, and G4. What is G1, G2 here is the gain here. So G2, sorry, G1, G2, G3, G4 for first path. For second path, G1, G2, and we have eliminated these G3 and G4. We have taken G5. Okay, so that is the forward path. We have two. And next comes the two non-touching loops. That is, sorry, forward path gain, and we have individual non-touching loops. What are the non-touching loops? And before going to that, make sure and we have two in. What are the individual loops? So this is an individual loop, and so this is your individual loop, this is your individual loop, and this is an individual loop. Okay, and depending upon the see, this is your see the direction of your in your signal flow graph. It's going in this direction, it's coming in this direction. Okay, so this is a loop, but see, this is not a loop. This is not a loop. See here, the direction, it's going in same direction. So this is not a loop. Okay. So you have to calculate single gain for single loops, and now we are going to for gain for non-touching loop. What are the non-touching loops here? So this is your so this loop, okay, and this loop is non-touching one, right? So calculate that G1 minus H3 and G2 minus sorry, G2 H1, and the other loop, we have other non-touching loop, that one is this one and this one, this whole. So these are the two non-touching loops. Just multiply it and you'll get the answer like this. And next one, you have to substitute this in machine gain formula. That's all. So we have path as forward path. We have two. Kindly calculate it, and a forward path and loop gains, and the sum of two non-touching loops, and del is nothing but 1 minus. We have to according to the formula, we have to substitute minus sum of gains of your loops, and sum of plus sum of your gains of product of the gains of your non-touching loops. Okay, that's what the del, and you have to substitute these everything in your Mason gains formula, and you'll get the transfer function. Okay, so that's all with the signal flow graph.